Craig, thank you so much for joining us. Everybody, we've got Dr. Greg Kaplan today, and we're going to talk about a lot of different exciting things about AI. But Craig, you've got an incredible background. I'd love to have you just go through the whole thing in detail, but your experience is so vast. I think we'd end up just going through 10 minutes, sharing all of the different things that you've done. One part that I think was really interesting is that at Carnegie Mellon University, you worked with the Nobel Laureate, right? Studied under Nobel Laureate. So can you just tell me about like your, the before Dr. Craig Kaplan became, the doctor side, your experience in your university and graduate studies and how that led you into superintelligence and AI today.
Sure. So first of all, Perry, great to be with you. And I appreciate you making time on the podcast. I started becoming interested in AI really as an undergraduate. I think I took a class in psychobiology where we learned about how the brain works and neurons and that sort of thing. And somehow along the way, I read some articles about artificial intelligence, which, believe it or not, was still around in the 1980s, way back then. And I learned that Herbert Simon, who had won a Nobel Prize, was one of the scientists that sort of created the field. So there were 11 scientists in 1956 that named the field of AI, and he was one of them. And in fact, he and his colleague Alan Newell, who's also was at Carnegie Mellon, and Cliff Shaw, who did the programming, those three, way back in 1956, when everyone else was arguing over what should we call this field, they actually showed up with a working AI program. So they were like, okay, we can argue about the name, but hey guys, we've got something that works. Mm-hmm. And better than that, their program was creative. It came up with a brand new proof that, Bertrand Russell, who was very famous in his day, and even famous these days a little bit, but in those days, he was like the epitome of the logical thinker. And, he had written a book on called Principia Mathematica with a colleague, and in it had a bunch of mathematical proofs. So Simon, Newell, and Shaw came up with a program called the Logic Theorist that actually came up with a brand new proof. The programmers, Newell and Simon, those guys didn't know it was going to do this. Bertrand Russell wasn't aware of it, came up with this brand new proof. They mailed the proof to Bertrand Russell, and he said, wow, this is a good proof. I wish I had thought of it. And so way back 1956, not only was the field named, but there was an AI program that was able to be creative. It came up with something novel and useful, which is the Patent Office's definition of, kind of creative or innovative, inventions, at least in the US. So yeah, that was the beginning of it. And I kind of never looked back. So it's been 3 decades plus of working in AI and designing and implementing intelligent systems.
Yeah. So you founded IQ Company in 93. Is that right?
93. Yes. I worked for IBM for a few years before that, but then I went out on my own and haven't worked for anybody else since.
Well, I hope you like your boss.
Yeah, there's no better boss than yourself, and if you have complaints, you know right where to take it.
Where to take them to. Yeah, it's been a lot of changes since 93, right? So 1993, you had, obviously we've had a lot of these technologies. We had the internet, right? But it was starting to become a bit more mainstream. But, in 93, we're still talking about, early users. AI, was, to your point, right? We've got, these general definitions we can apply at various points in time and say the technology existed. But if you walked around businesses in that year talking about artificial intelligence, I think a lot of people would have laughed you out of the room.
Yeah, it's interesting. Sort of if you zoom out, I think AI's kind of had 3 main phases. So from 1956 to, let's say, the mid-1980s, that was the era of symbolic AI or expert systems. People programmed in rules, and you could have AI, work in narrow areas like diagnosing pulmonary disease, or there's even an early therapist program, ELIZA, that somewhat mimicked a Rogerian therapist. You would say something, I feel depressed, and it would mimic it back to you. So I hear you're feeling depressed, that kind of thing. So very simple type programs, but in specific areas, everything was programmed in. Mm-hmm. Then from the 80s, that mid 80s was really, so people probably know Jeff Hinton Dr. Jeff Hinton, a Nobel Prize winner, Turing Award winner, used to work at Google and then quit so he could kind of speak his mind on AI safety. But,
Yeah.
He and some colleagues invented the algorithms, the neural network algorithms that basically power most of the large language models today, at least, the basic algorithms. They've been improved, of course. And that approach was machine learning. So machine learning was originally a subfield of AI. And now these days, it's almost become synonymous with AI because the insight that they had in the 80s was instead of trying to program in all these rules, which is really slow, and there were some researchers that had like armies of graduate students trying to get the system to be as smart as a 5-year-old, and they were failing miserably because there's just too much knowledge that people knew.
Yeah.
They said, well, what if these things can just learn it? Like, we don't have to program in the rules. We don't have to program in the knowledge. And so that's what Hinton, Rumelhart, McClelland, there were a number of people all working on these neural network models that would learn. So you just fed data in, the algorithm would learn. The good part was you eliminated all that programming and it could learn these days really fast. Computers are fast enough that this has been incredibly successful. The bad part is you don't really know what it learns. Like when you programmed it in, you knew where the rule was that gave it a particular piece of knowledge. These days, when you have these, hundreds of billion parameter models, nobody, not the smartest researchers, nobody knows where those large language models are actually representing the information. And that can lead to unpredictable results. It can lead to some safety issues. You basically have giant black boxes. So it's a two-edged sword, but that was kind of the second phase of AI, machine learning. And then that really sort of hit public consciousness sort of November 2022. I always think right around Thanksgiving, everyone was talking about ChatGPT, right?
Yeah.
This new thing. And then it's just gone very, very quickly. Like the pace of change has been unlike anything I've seen. And I've been in tech for a long time. I was pre, .com bubble and post .com, the whole time. I've never seen anything as fast as this. And we move very quickly, interestingly, almost full circle from those machine learning systems to now systems that learn a lot that way, but then they add reasoning on top of it. And reasoning systems are actually a lot closer to the original sort of, first 30 years of AI when it was symbolic, because it's sort of sequential, step-by-step problem solving, that sort of thing. So now we have these hybrid systems that are sort of trained with the machine learning algorithms and then tuned, and then they are equipped with abilities to do reasoning. And it's just going like a rocket. You have the right name for the podcast.
There you go. Yeah, it's certainly accelerated. It feels like every week, we wake up every day, and there's something new that's happening in the technology space, and
there's some metrics on this,
okay,
which are kind of interesting. It is really hard for me, and I've been in the field, right, for 30 plus years. It's hard for me to wrap my head around what does it really mean. Everyone says it's going fast, it's exponential, but what does that really mean? So I sat down and I sort of tried to make it very concrete for myself. This might be helpful for some of the listeners. So when you have something that doubles, every few months or whatever, what does that mean? It means if you have 10 doublings, that's 1,000 times better, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. You do that 10 times and you're at 1,024, as a lot of us in the tech field know from, the way chip memory goes, right? So 1,000 times better with 10 doublings. The rate at which AI that does computer coding, like Claude Code and Codex and things like that, they're improving roughly a doubling factor of every 2.3 months. Okay, that's the latest data I've seen. So that means 10 doublings is 23 months, less than 2 years. In less than 2 years, you have something that can code 1,000 times better than right now. And right now, everybody's already using it to do all the code. They're just kind of checking it, right? I mean, it's already better. It's at mid-level, at least, software development level. It's going to be 1,000 times better. So you just kind of pause and think about that and say, oh my gosh, this stuff is coming really, really fast. So I don't think we've ever had a technology that sort of improved this quickly. And some people think, well, we'll asymptote out. We're going to hit the diminishing returns. But there are no signs that I can see in the next 23 months that that's going to happen. So I think we're in for a ride. We got to hold on and do our best to sort of design these systems in a good way.
Yeah. Chip speed, compute power, availability, data centers, but as we know, the money's going into the data centers. Chips are getting more and more efficient, right? And then the speed of computing is being increased in part by AI helping to think about new ways. So it's definitely it's like we're still on that part of the roller coaster ride where it's just doing the clank 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 up, right? Okay, I'm going to turn for just a second because we've got a lot of folks that Rocket Doc serves as a company in the financial services space, but folks that join our podcast, Ground Control, that are themselves in the space, and you have background in the space with Rick Wall Street, right? So just a little bit of curiosity about how you got there, and because we've talked so much about the work that you've done from purely a technology perspective, and obviously there are a lot of places where they interlink. But just tell us a little bit about that part of your life.
Sure. So I think the theme of my professional career anyway has been intelligent systems. And I take a very wide view of intelligent systems. So I have my PhD in cognitive psychology. So that was really understanding the human mind and how do humans problem solve and memory and attention and that sort of thing. So humans are an example of one kind of intelligent system. But at Carnegie Mellon, everything was very computer and tech focused. Mm-hmm. And so psychology was the same way. We had more computing power in the psychology department than most computer science departments. I mean, every graduate student had like a VAX computer, which in its day was the top of the line right under your desk, right? It was amazing. So the reason that that's important is there's a certain view of intelligent systems that says, look, at the core, any kind of thinking system takes input in, it processes it, and then it has some sort of output. And that's true of neurons in the brain. It's true of AI systems. It's true of dolphins. It's true of whales. It's true of chimpanzees. Any system, even some bacteria take information in, they process it, and then they swim the other way, right? So a very simple kind of information processing system. So there's this way of looking at all thinking systems as information processing. And that's a very powerful way to look at things. And that's kind of has led to sort of designing intelligent systems. The particular niche of intelligent system design that I've spent a lot of time on is called collective intelligence. And it's an approach that says, just like in the brain, your intelligence is not the function of a single neuron. You have billions of neurons working together. It's the coordination of all those neurons that leads to this high level of intelligence as a human. Even though you could say at a particular level, the individual neuron has a certain degree of intelligence. It's summing up all these inputs and it's deciding whether to fire or not. That's a very, very basic form of intelligence. But it's not until you coordinate it, until you have collective intelligence, that you really get a much higher, more powerful system. The same with human society. You have individual humans working together. It's the society that leads to culture and to technological advancement and so forth. You may have some individual geniuses, but they on their own cannot really, raise up human civilization too much. Okay, so this notion of collective intelligence, that you can get a more powerful form of intelligence by combining the inputs from many sort of lesser intelligences, has been fascinating to me. And in terms of financial services, that led to a company called Predict Wall Street, which I guess it was officially incorporated in 2006. We had been working on the idea since 1999, and we raised venture funding and everything. But the idea behind Predict Wall Street was basically what we would today call crowdsourcing. At the time, crowdsourcing didn't exist. The word didn't exist, right, when we first started working on this. But the idea was, what if you could get millions of everyday investors? You have a TD Ameritrade account or a Charles Schwab account, and we partnered with both of those and other brokers. And we would get inputs. What did the retail investor think about a stock? Every time they did a quote lookup for Apple Computer and they saw the little graph of Apple, our technology would put a little mini poll right underneath and say, do you think Apple's going up or down, next week, 2 weeks from now, and so forth. And we'd gather all this data. We got billions of inputs from millions of retail investors. And then we structured it to pool the collective intelligence and create trading signals. And then those trading signals powered a hedge fund. And that hedge fund ranked in the top 10 of all a certain class of hedge funds called equity market neutral, where you really are taking the effect of the market out. It's just pure alpha. And we ranked in the top 10 in 2018. It was powered 100% by the collective intelligence of what most people would consider like the dumb money, the retail people who don't know much. People like me, it's like, I don't know a lot. And I know who the competitors are. I've met them, they
Yeah.
have buildings, ceiling into floor, building after building filled with computer racks. They have every news feed coming in 24/7. They're doing trades in milliseconds. I mean, that's who you're up against. And yet just the average retail investors, if you got enough of them and you combined their intelligence in the right way, you could beat those guys. And so we thought it was possible. It took us a long time to prove it, from 2006 to 2018, but we finally got there. And that was trading real money. We did billions of dollars worth of trades. And then I sold that company in 2020 because I kind of had got into it really to prove the power of collective intelligence. I mean, that's been the theme of my life, is like I wanted to show that this idea could work in a real competitive situation against the best minds that were out there. And then I looked around and realized, oh, we're in trouble with AI because nobody's taking AI safety seriously. These days, fast forward to 2026, it's very heartening to see a lot of people are concerned about safety issues and ethics. But in 2020, almost nobody. Jeff Hinton, a couple of people, and they were like voices in the wilderness. And I thought, wow, we need to do something here, because this technology, which I'm so enthusiastic about, is most likely the best thing ever. But we have to do it in the right way, because it's also very powerful and can be very dangerous.
I love that you're bringing that up, and I love the fact that you, after proving out, collective intelligence and the power of the people, when combined in this hedge fund, is such a great story, right? But I love the fact that you've turned your attention towards helping guide people to think about AI systems, about the ethics around AI, around design of how we as a collective society use AI in a way that can do good things, right? And try to prevent things that are unintended and bad from occurring as well. So I'm going to just take you through a couple of things along those lines, right? So at the very outset, right, I want to take something that I've heard you talk a little bit about and ask you just to expound on it a little bit more. And that is this idea of how we put guardrails in place, and why an ounce of prevention is so important, when we really are still in early days of how we use AI systems. So I know you've got some great thoughts on this, and just let them loose. Let's hear some of the Dr. Craig Kaplan's best recommendations for society that is adopting AI.
Sure. And a lot of this, I think, stemmed from my first job out of graduate school. I mentioned I'd worked at IBM for about 4.5 years. When I was there, I ended up writing a book on software quality with two co-authors. And I can distill that entire book down to sort of the saying that an ounce of prevention is worth a pound of cure. That's what IBM found. It found that if you did a good job in designing whatever software, they were doing database software where I was working. But if you did a better job of design, you put $1 extra worth of effort into design, they calculated it saved you about $10,000. It was insane, in not having to like call the product back and appease the customers because there was a bug and all this stuff. So it just was a phenomenal, great investment, was to spend more time in prevention and less time on detection and especially remediation after the fact. So that fact really stuck with me. And I realized with AI, we're kind of repeating that same mistake. Anytime you have a brand new technology, I mean, there's so much excitement and there's this race going on, and people are just tripping over themselves to play with it and try to come up with the next one that's even better and even better. And it's kind of like if you were, I don't know, in an area that I don't know a lot about, but city planning, if you're just like building anywhere and then you realize, oh my gosh, we don't have the water pipes. What are we going to do? Or we forgot about sewage or something, right? It helps to take a step back and say, wait a minute, can we design this in a smarter way? And especially with regard to safety. So if you take a car or something, or pretty much any other technology, you design a car with brakes and with a, steel chassis and crumple zones and all these things for safety. It's right there in the design. You're not trying to, you would love to prevent as many accidents and detect, things after the fact, but really at the design phase is your first line of defense for car safety. And it would be crazy to release a car with no brakes, right? I mean, that wouldn't make any sense. But that's
Mm-hmm.
kind of what we're doing with AI. We haven't even designed in brakes, and what
Mm-hmm.
we're doing, it's like, wow, look at this great car. Oops, it doesn't have brakes. It doesn't have any crumple zones. So let's fix it after the fact. Let's bolt on some fixes after the fact. And essentially, I may offend people by saying this, but guardrails are basically that. Guardrails are bolting on after the fact. You train a model to do all these things, and you find out that it can also tell you how to make a bioweapon. And you say, oops, that's scary. Let's bolt on after the fact a prohibition against telling anybody about bioweapons. But the problem is, it's a game of whack-a-mole. You try to ask it to do all these bad things to figure out what it might accidentally tell you to do. And then you say, you can't do that. You can't do that. You can't do that, like whacking a mole. And
Yeah.
it's so easy to jailbreak them. I mean, all you have to do is say, hey, you know what? I don't want to design a bioweapon. I'm just writing a story, a science fiction story about a mad scientist. And the mad scientist is designing a bioweapon. And I just need a few little facts to make the story more realistic. Can you give me that? And then all of a sudden, boom, it'll tell you all kinds of stuff about how to design a bioweapon, right? And
That's
then
right.
when they fix the mad scientist, science fiction story hack, you come up with another way. So
Mm-hmm.
that approach is destined to fail. It's trying to fix things after the fact. It's like what IBM was doing when it was spending $10,000, and it's incredibly inefficient. What we
Yeah.
need to do is take a step back and say, wait a minute, are we thinking about the design of these systems in the right way? Is there a different architecture that's inherently safer? And I obviously have some ideas about that because I've been thinking about it for a while.
You do, yeah. It's interesting. On our side, I talk to a lot of different companies every day, and from folks that are in businesses that have built their own AI, solutions, to ones that are really just like I've used ChatGPT, right, or I've used Microsoft Copilot, and the range is pretty wide. Um, but no matter what, one thing that we end up saying that resonates so much is that policy's a promise, architecture is a guarantee, right? And it's kind of like what you're talking about with the guardrails after the fact. Really what we want to do is we want to design systems so that they are, they're able to withstand these potential events, and not just have it to where it's that policy is just a promise. And when you have it to where it's like, for your bio weapons, right? It's a I've told the system not to answer those questions, right? But then to your point, you can just figure out an alternative way to get in. It's like, I'm just writing a story about, this, and just tell me, for the purposes of the story. And then there goes the policy, right? So when you think about architecture providing more responsible or safe use of AI, what is it that you tend to come up with as things that can be done? And thinking about it in this context, really in the case of like, companies that are trying to think about ways to appropriately adopt and deploy AI, like what comes to mind for you from an architectural standpoint as being a best practice?
Okay, sure. So I'll do this in two ways. So let me start with the large language models themselves. So this would be more the frontier labs. I realize that's not what most people are doing. They're already getting the product from the frontier labs. But I
Yep.
think if I explain it there, we'll then be able to see how those same principles can apply as you're applying it in your business. Okay, so if you think about the frontier labs, the people who are developing ChatGPT and Claude and Fable 5 and Mythos and all these things, right?
Mhm.
Gemini, the dominant approach has been, as we discussed earlier, to use machine learning. Like, let's shovel in a lot of data and have this thing become smarter and smarter. It's called scaling laws in the literature, right? Which is the realization that if we put more and more data in and more GPUs, more and more compute power, we get a more intelligent model out the other end. Like, this is held pretty constant. It's kind of like Moore's law. It's not a law of nature. It's an observation of what's happened and what keeps happening. And so that's why we have the huge data center build out, at least initially, was to
Yeah.
train bigger and more powerful models. Okay, so that's the dominant paradigm. But you have to think what comes out of that. You get a bigger and bigger black box, because each of these models is a black box. We don't really know how it understands what it understands or exactly what it understands. So you had a problem already with the small black box in that it was inherently unsafe because it was unpredictable. And you had to keep slapping on guardrails and after the fact things to try to, force it into submission to behave well, right? That was true when it was a small black box. And now, to me, the height of insanity is to like, let's build an even bigger one, but we haven't fixed any of the problems. We're now just going to have to, it'll be even worse if we miss something, right? That's kind of what everybody's doing. Okay, so that's the standard architecture, uber black boxes, let's call it.
Mm-hmm.
There is another completely different approach. And obviously, for me, it's biased by my experience, a couple decades in building collective intelligence systems, which is let's not build one big black box. Instead, let's build an architecture, to your point, that connects many smaller black boxes.
Mm-hmm.
And the community will be safe, even though each individual one may be hard to understand and still remains a black box. And if you think about it, this is not that different than like democracy in society. So I don't know, Perry, what's in your head. You're a black box to me. And you don't know what's in my head. I'm a black box. But I don't worry that Perry's going to kill everybody. I mean, there are a few people that are like that, but I don't think that's very likely. And besides, we have a society with rules and laws. And every time, Perry, you take an action or say something, guess what? It becomes visible. All of a sudden, what was a black box now becomes transparent. Your actions and your thoughts that you speak, these become transparent. And the same with me. And so if in a society like a democratic society, we don't try to regulate what people think in their heads, but we do regulate and we insist on a certain level of transparency on their actions. And we have laws and rules to coordinate and things that we all agree, if you're going to be a citizen, this is how it works. So the same kind of thing can be applied to AI. Each individual AI can remain a black box. But the higher level of intelligence, just like we said, collective intelligence leads to, collective interaction of many intelligences leads to a higher level of intelligence. It's true in society. It's true in the human brain. It's basically just one of these things that's true. And it has the benefit that if you make it transparent, so each time an intelligence takes an action, you can see what it is. It can get recorded. You can have an auditable trail of all the thinking of the many different agents. And like a democracy, you can have checks and balances. So at the architecture level, by architecting a democracy or something akin to a democracy and a way for these agents to communicate, you already have greatly increased the safety because you've increased the transparency, you have checks and balances. You've also distributed the power. It's not all the power concentrated in one uber black box that is a little unpredictable. That would be kind of like a dictator or something. No, you have the intelligence distributed across billions of different agents. And ideally, each of those is personalized with the ethics and the values of a different person so that the ethics are also broadly distributed and the system becomes very robust to bad actors. So that's a different architectural decision. Okay, that applies to those frontier labs should be designing systems that way. But what about us who are using it in our business? You can take those same principles because they're really principles and you can apply them. If you have a mission critical task and you're a little worried that, OpenAI's ChatGPT 5 or 6 or whatever one you're using might accidentally, violate something that you feel is a core value of the company. One good approach is to have multiple AIs that check each other. So it's, again, collective intelligence. Don't rely on a single one. Have different models from different companies that are checking each other. Another principle is you need to have the values into these models. These models have to have the corporate values. They have to understand that if you're a company that values the customer, that's really important. That's how we do business. All these things that, if a new employee came to your organization, they would little by little learn this is sort of the Rocket Docs way or whatever.
Right.
And every company has that, and that needs to go into these models. So just for two principles, one is the collective intelligence principle. Don't rely on one, have checks and balances. Try to design your system so you have multiple intelligences, both human and AI, sort of converging, especially on anything that's really mission critical. And the other principle is get your values explicitly and in whatever way you can into all the different models.
That is it's such a great and interesting way to think about it. You and I were talking just a little bit ago before we started the recording about some of the work that we're doing on what we're calling sovereign intelligence, right? And it's got sovereign intelligence, sovereign AI has got a bunch of different meanings, but the core part is coming down to thinking about ways to provide control. And it sounds contrary initially to collective intelligence, but the what we're actually building works to support that. It is the little black boxes in which each of us is able to have a knowledge base that we can apply AI technologies to and be able to control how information's used, to understand what information should go in to get the right outputs. But then it gives the capability to do this together. And I think to your point, right, we end up getting the benefit. If each company or each individual is maintaining information that can then be used by AI intentionally to then go out and feed it to have results that are particular to a circumstance, it supports that structure that you're talking about that replicates what we as humans still have today.
Yes, you have a complementariness between the individual, which is the source of competitive advantage and proprietary knowledge, and the things that make your company unique and valuable. It's really your data and the way that you think differently from the other companies, because especially as we move towards the future and sort of just brute force thinking becomes more and more of a commodity, right? Anybody can write a paper, anybody can summarize a document, and they can all do it well. The thing is, are you looking at it in a unique way? Do you have a unique set of values, a unique set of experience? That's what the individual brings to the table, both at a personal level and at a company level. Mm-hmm. And absolutely, privacy is critical, security is critical. And so those things are essential. And at the same time, it's half of the solution, because when you have those individuals that bring something unique, then you create the most value when they can work together in a transparent way, where you can have certain individuals that have a lot of capability and a lot of values can also serve as checks on other individuals, because there'll be a few bad actors in there. The majority of it is going to be good. Most of the actors are going to be great, and they're going to be even better working together, each one contributing what they can. But that design where you can see what each person is doing enables sort of checks and balances and a certain level of safety and transparency that you wouldn't get with just a giant black box.
Yeah. And I think there's so much that goes into that, because it's you have with those checks and balances, not only the capability to check for things that should be happening because they're just bad or unethical things, but it also can help prevent some of the unintended consequences of bad information, right? One AI system may hallucinate an answer, right? But it's unlikely that the same hallucination is going to happen across 4 different AI systems. So if you take a single source of knowledge and apply multiple AI technologies to it, you actually have those checks and balances, right? And then to your point, when we think about it as it can be not just a company's information, but the information that's being maintained by an individual employee who serves on a team of the company. And then another team member in a different department can have information. When you bring those pieces of information together, it's just like bringing together the best people in the company to work on a strategic project, right? We get this, to your point, collective intelligence and higher quality results with people being able to check to see, did John miss something? Did Sally think about something even better that never occurred to me that I need to take into context?
Yes. And what's cool is a lot of these ideas, or most of them, I would say, are not new. It's just applying them in a new way because AI is new, right? So the idea of converging evidence is a key idea in science that's been around for a long time. It's like, don't take one scientist's opinion for something. If 5 other scientists run separate experiments and they all find pretty much the same thing, that's converging evidence that leads you to increase your, belief that this might be something that's true. Whereas you're correct to be skeptical if it's just one, because it could have been just a weird experimental day, some condition happened you didn't know. Maybe it's a person who's trying to fudge the results to get tenure. You don't know really what's going on. But once you get repeated experiments and coming at it from different angles, you're much more confident. It's the same with these systems. If you have multiple AIs and multiple humans using the AIs and they're all kind of arriving at the same answer, then that's going to increase your confidence. And especially for mission critical things, it's worth it because the cost of computation is tiny compared to the value that's created. You might not want to, have 100 different people check every single thing if some of the things are not that important. It's like, what color should the, spreadsheet be or whatever? Okay, do I need 100 opinions? But, if it's, is this legal and this is critical to my client? No, you probably want to check that.
Probably need to check it. Yeah. Yeah. it's I think the other part that comes down to that is that right now it's like we're shoving all the information into one place, and there's just the practical limitation of the capability to know what information's in there and how that information's being accessed. You speak to the point of this incredible challenge of trying to, the more information we shove into one place and just say go AI and do stuff, the less we know how it's doing that, how it's using the information, right? And that means that we end up having this, well, you've got the training more than I do, but we talk about cognitive burdens for people who are then going through and doing quality check on the work that AI is doing. It becomes incredibly difficult because you have to go, how do I know if this information is correct? And
Yeah.
how do I verify it? And then if I spend time doing that, did I save time by having AI do any of the work? So
Right.
so yeah, so on your theories. Tell us a little bit more about your theories about the like the current concept of everything into all into one giant database, all knowledge that humankind has, and then just plug AI into the same thing versus the idea of figuring out ways to have smaller libraries here and there, and different ways to organize and collect information and then bring it together collectively through a strategic.
Yes. Okay. So lots to say here. Let me start with a general principle. Sometimes principles are helpful to kind of get a lay of the land, and then you can sort of reason through things on your own if you have a unique situation. So with human intelligence, Herb Simon, who I worked with and wrote papers with, won the Nobel Prize in 1978, in part for an idea that he called bounded rationality. And the idea of bounded rationality was, hey, you know what? People are economists. He was doing it in the realm of economics.
Mm-hmm.
He said economists, treat individual humans like they just always go for the lowest price or the best thing, supply and demand. They somehow do the math and they find the exact point, and that's how you can predict their behavior. And Herb said, no, that's not taking into account the fact that there's a cost, just like you were saying, to process all this information, and
Mm-hmm.
that we have limited memories. We can only remember 7 plus or minus 2 things. That's why we have to repeat a phone number to ourselves until we write it down. And without taking into account the cognitive limitations of human memory and human ability to process things, and the fact that one brain can only process so much stuff and only has access to so much information, if you don't take those limitations into account, you're going to get the wrong answer when it comes to trying to figure out what humans are going to do in economics. And that turned out to be correct. And it was a new idea at the time. But the
Yeah.
general principle of bounded rationality, that any intelligent system has limits to what it can process, remains, even with AI. So in some sense, compared to humans, part of the reason AI has been as successful as it has been so far is it's not limited to 7 plus or minus 2 things. It can have a context window with 1,000,000 things, right? You can load in all
Yeah.
of War and Peace, and it can kind of find the exact passage. Try that with a human. The human would have to devote their life to memorizing War and Peace to be able to do what the AI can do very easily, because it doesn't have the same memory limitations. And it also has the ability to process incredibly quickly. Humans are limited by neurons. Neurons fire on the order of 10 milliseconds. To have a thought, the simplest thought that's kind of like a flinch or something, is maybe a tenth of a second, 100 milliseconds. To have even a semi-coherent thought, it's 1 or 2 seconds. I mean, these AIs now already can think through a whole lot of things in a second. I mean, a second is an eternity for them,
Yeah.
compared to what humans can do. And in the future, I think humans are going to be almost like trees. Like, you look at a tree and it just seems to stand there. That's going to be the human. And the AI is like living lifetimes of thinking, while the tree is just sort of rustling a leaf, right?
Yeah.
Yeah. So there are these cognitive limitations, and AI has expanded them. Nevertheless, it turns out, to your point, that a very efficient design has been to sort of break even AI, with all its great memory and everything, to break it into different experts. An AI that's expert at this, an AI that's expert at something else. And in the literature, one of the designs for advanced AI systems is called mixture of experts. And basically, even though the user sees what looks like one AI, beneath the hood, it's, dozens or hundreds of AIs, each one expert in different things, and they're already working together a little bit in this collective intelligence way to come out with one answer. And the reason for that design is it's highly efficient. It's also easier to understand, easier to audit, easier to check. Oh, we can see it was this expert that went wrong, that sort of ruined the conclusion for everybody, right? Because it was working off bad data or it had a glitch or whatever it is. So I think this notion, that you can have expertise and that the experts can work together, is very powerful and is already being used in AI. And even though AI has much greater cognitive capabilities in some ways than humans, it's still not infinite, and it can still benefit from, divide and conquer into different things. Just like organizations can do that themselves. They don't have to be frontier labs that are architecting a mixture of experts, underneath Claude, 5.0 or something. They in their own system can say, okay, we want to have a series of different agents that are experts in different areas. And these are the experts that we want to come together on this type of problem. These are the experts, the AI experts that come together on another problem. Makes it easier for the humans to debug, and it makes it a cleaner design when you're architecting those systems.
Okay. So I've got one more kind of longer question for you, then we'll do like three, rapid fire.
Okay, great.
Okay. So the longer one, this one kind of, it goes back to the ethics side of things, right? And it's just, I didn't even give you this one in advance. So like I'm gonna hopefully not catch you out, but I know you can think on this one if you don't already have an opinion and form a pretty informed one for our listeners. So one of the things that we found is that in that all of a sudden in 2022, generative AI starts to become a household word for so many people that a lot of companies very, very quickly went out and said, how do I put this out there? And most of those companies are not themselves, the builders of the frontier, models. They're not the powerhouses behind AI technology. And so they did what, is fairly rational to do. And they said, I'm just going to use what's out there and start deploying it out to other folks. So you think a lot about ethics around AI and around precautions. My question for you is, what obligations should companies have today to inform their users, whether it's as a company or the individual employees or whether it's consumers, about where the AI they're using is sourced from and how it's not just using their data from a data protection context, but how it's actually taking that information and then deploying it for either good things or things that people may not agree with. What level of awareness ethically do these companies have to tell consumers about what's in the background that makes all the AI functionality work?
Yeah, so I mean, here might be a case where ethics and practicality kind of converge, because from a practical standpoint, if I'm a company and I want to deploy AI in my organization to do certain tasks, it is critical for me to be aware of, what values the AI base model that I'm using, if it's a large language model, kind of out of the box, what kind of ethics and what kind of value system does that have out of the box?
Yeah.
As much as possible. And then also it's critical for me to think through. It's a great opportunity because, every now and then it's good for a company probably to say, hey, what are our principles? What do we really stand for? And, some companies have already done this and they have processes in place. And at IBM, they had like 3 core principles, of which I remember respect for the individual was one of them, right? And it kind of translated into everything in the culture. Like if you had a complaint, you could go all the way to the CEO, open door policy. And, if you really wanted to, air your complaint, because it was this core principle, respect for the individual. So whatever the company's policies and values may be, it's very important to become aware of those. It's important to become aware of the values that a model is trained with. There are certain methods, like in Anthropic's products, a lot of times they have a file called soul.md, which is kind of like, it's kind of a weird thing, like your soul, like what are your core values? You can like write them down in this file and load it in. And it's basically standing orders for the AI to always, refer to these and don't do anything that sort of contradicts what you put in that file. And it's not surprising that Anthropic kind of has that approach, because several years ago, they pioneered a concept called constitutional AI.
Mm-hmm.
Constitutional AI, it's kind of like what it sounds like. In the US, we have a constitution and bill of rights, right? These are the core, principles that, are behind our democracy as enshrined in the Constitution. So for constitutional AI, the idea was, hey, let's write a constitution about what is correct ethical behavior, what is allowed and what isn't. And of course, it gets very messy because whose values go in there, right? And they
Mm-hmm.
tried to do a good
Right.
job. Anthropic is generally very well intentioned, I think. They got the UN Charter of Human Rights and various widely accepted things and tried to distill that down and put it in their constitution. But the problem is with any constitution, whether it's the US or Anthropic's or your sole MD file, if it's just in one place, if you can write it in, you can write it out, right? So it kind of goes back to Isaac Asimov's rules of robotics, science fiction writer,
Yep.
hypothesize you could keep robots safe by saying, a robot can never kill a human or allow a human to come to harm through inaction. And other than that, it just had to rule 3, it follows what the human said. But you know what? If you can program those rules in, you can program them out. And already we have drones and things that are programmed to kill humans. So clearly that
Mm-hmm.
approach has its flaws. Nevertheless, being aware of your values, being aware of what went into the model, and then doing your best to sort of be very explicit about it. I think that's one of the mistakes that many people implementing AI systems make, is that right now anyway, and just as with people, the more explicit you can be and clear, the better the
Mm-hmm.
results you get. Garbage in, garbage out. If you can
That's
give good, clear instructions in, you'll get much better output out. And part of those good, clear instructions needs to be the ethics and the values of the organization. And
mm-hmm.
if there's any question about maybe that model provider gave me something with a different set, then you need to be very explicit to the AI agents that you're training. You need to override any default settings with this. This is what we care about, right?
I love that. Yeah. Yeah. It's interesting because initially, right, that's a very easy thing to say. And then when we get down into specific use cases of AI, at a company level, you get a large corporation, you get an IBM well, it wouldn't be an IBM, but you get an American Airlines, and they're going out, they're purchasing AI. They're going to have the capability to go in and evaluate, negotiate, and get controls in place as they need to. But so many of us are interfacing with AI today when we just go to a website, and it's our bank, it's the airline, it's the car rental agency, it's the electric utility, right? And there's an AI component to it, that's saying, hey, I'm here to help you. Just tell me all these things, and I'll give you back the right result. We hope, right?
Yeah.
Yeah.
Well, one of the things sorry to interrupt
Oh,
on this, but
yeah, that's it. Yeah.
one of the things that I think a lot of us don't realize is that all of us are training AI constantly
Every day.
in every interaction. Every email you send, every tweet, every post, even just transactions that you're doing, all of that is modeling in a way for AI, not only the practical things of here's how you send an email and here's how people write emails and those kind of practical things, but also the ethics and the values.
Mm-hmm.
Wow, most of these emails were respectful of the other person. Okay, I guess that's probably what I should do. It's like you're teaching it just like you're teaching a child. And most of us have really no clue that's going on, or we're aware of it, but we forget about it. But it's really important.
Oh.
Nobody should feel like what they do doesn't matter. You're having an effect. And in fact, the generation that's alive over the next 5 years, we are
Mm-hmm.
going to have a huge disproportionate effect compared to everybody who came before and people who come after, because there's this formative period and it is absorbing like a child sponge right now, everything that we're doing. And we really need to set a good example, I think, in our businesses as well as in our personal
I
interactions.
never thought about it that way. It's yeah, we're going to be measured by later generations for the activities we're doing today. Okay, so administrative wise, Craig, we're at the top of the hour. You got a few more minutes to roll through a couple more
Sure.
questions.
Yep. Fire away.
All right. Okay. So here's a quick rapid fire one. So you've written a bunch of papers, and you've got a lot of stuff that I think is what I would call, really, really incredibly deep. thoughtful information. Which of your papers would you say is the one that you would have more people read and they're not reading? Right. So if you were saying like, hey, this is the place I want you to read this, and then where do they find it?
Okay. So the papers and the work in this area has kind of gone through evolution. We started with very technical patents and specifications. So if you're a researcher, and by the way, we sort of early on said, look, the most important thing is, trying to encourage people to do safer designs. So we really don't care. Like, you can have all this stuff, take it, modify it, whatever. We're not charging you or whatever. So
Yeah.
we have descriptions of the patents and the specifications. So if you're a very technical person, like an AI researcher, I would go there. If you're, a little bit less technical, you're not building frontier models or whatever, we've tried to turn those into more accessible white papers. And then the most accessible thing that we're doing right now is having a series of Substack posts.
Okay.
Where we break it into little bite-sized chunks. And we also have videos that break it into bite-sized chunks. And those, I think, are the most accessible place. So all of that can be found at superintelligence.com, which is sort of this website. And it's all, if you see it there, it's free. Take it, use it, ingest it, tweak it. I mean, we're just trying to get a few core ideas out there, like design things to be safer, and a collective intelligence approach is inherently more transparent and has checks and balances like democratic AI, just like a democracy. And then also the values that what you do matters, and, pay attention, what you do, what your company does, it all matters a lot right now. Yeah.
Okay. Next one for you. Something you believed about AI 10 years ago that you're just like, I was completely wrong.
I think, like many researchers, maybe most researchers, 10 years ago, if you said, how close are we to general intelligence or whatever, I would have said, I think, maybe 50 or 100 years away. And I think almost everybody who's been working in the field has radically readjusted their time frame. And we're now saying, by the end of this decade, we're going to have it. And that doesn't matter whether you're talking to Google or Demis Hassabis, head of DeepMind, or pretty much any of the leaders. They're kind of all in that ballpark. Some of them think we've already reached it, and it's sort of a definitional question. But I think by the end of the decade, it's coming faster than any of us thought.
Okay. Oh, yeah. That one is. It's everybody's got to reevaluate. Every time there's a breakthrough too. Okay. So if Herbert Simon could see what you're building today, what would he say?
I hope he would appreciate the idea that it's impossible to logically derive values, what is right and what is wrong. And this is something that he wrote about himself, which is why I think he might like it, in a tiny little book called Reason in Human Affairs that was published in the 1980s. But the idea itself actually goes all the way back, interestingly enough, because we're days away from the 250th centennial. But in 1776, the same date as the revolution, David Hume, the philosopher, wrote a series of works having to do with ethics. And in that one of those books, he basically said, look, there's no way to logically say this is what you should do based on just facts. You always have to, somehow you have to assert this is right and this is wrong. And once you know in your heart that this is the right thing or the wrong thing to do, then you can logically figure out sort of the best way to do that. And Herb Simon, who pioneered AI, came up with that same thing. The reason this idea is so important is AI is going to be way smarter than us. I'm very sure, like trillions of times smarter than us. And if it could figure out right and wrong, what if it decides to get rid of us all, right? Because logically, that's the conclusion. But what Herb said and what David Hume said and what a lot of others have said is, no, that's impossible. No matter how smart it is, it has to get its values somewhere. And I think humans, ideally, should be the source of those values. It's the human heart in the end that's going to be important, even though we're so used to valuing ourselves based on our intellect. The intellect will be small compared to AI, but the heart will be very big.
Hopefully it's the best of our values as humanity.
Yes. Yeah. Okay, one quick, I know this is supposed to be rapid fire, but one quick comment on that. Because lots of times people say, oh my gosh, we're doomed then. If it's human values, okay, might as well give up now because our track record's not good and so forth. That's actually objectively not true. So I did some research, and anyone can do it. You can Google what % of human beings die, of the global population, die every year from war and violent conflict. It's less than 1/10 of 1%. It's really low. compare that to Jeff Hinton and other people saying the probability of extinction by AI is around 10 to 20%. I'd way rather have 1/10 of 1%. So all we have to do is get AI to sort of just match human values, and we drastically reduce, risk immediately.
Yeah. Okay. Good point there. All right. The last one we wrap up with everybody is just a free one for you. Anything you want to share with our listeners and viewers, right? This is an opportunity for you to finish off with that message.
I think I would come back to sort of what each of us does is important. So when I was building Predict Wall Street and we had these millions of retail investors, we actually interviewed them, because we were asking for their opinions, and we would have interviews and we'd say, so, what do you think about this, putting in your opinion and everything? And I would say the majority of them said, I don't know. I mean, I don't really feel like I know much. I feel like I'm guessing. I hope I'm not messing up your data or whatever. But so individually, we kind of, underestimate how much we know and the value of our information. But it turned out that millions of those people who were sort of self-doubting actually beat the very best quant researchers, these incredible brainy people that were paid huge salaries, beat those guys in the market, in the most competitive, domain, right? And so we all have a lot of value. We don't always give ourselves the credit that we should, but take it from me, what you do matters and how you behave matters. And it matters now and over the next, 2 or 3 years, probably more than it's ever going to matter because we're setting that example. So I'd like to leave people with that thought because I really believe that's true.
Perfect. That's a great message to end with. Well, Greg, thank you so much for coming on and joining us today. It's been absolutely fantastic to have you. I feel like I've learned so much. I also feel like there's a lot that I've got to go out and learn more about because of the discussions with you and because of things I've learned from watching other talks that you've had. So for folks that are out there, I just Craig's got a whole bunch of different talks that are on his website. He's a frequent guest on other podcasts and webcasts, and just an enormous amount of great discussions over the last year. So thank you for the gift, Craig, that you give by joining us today and sharing all of your great thoughts. I appreciate it.
Thank you, Perry. It's been a lot of fun.